analyze this page fault, how to solve this page fault problem. We have some algorithms, page replacement algorithm for that. Let us see the first understand the concept of page fault. So if there is ever a reference to a page, you don't have reference to one particular page at all. First reference will be trapped to OS. That should be informed to OS, right? That should be taken as page fault now. So I need to overcome this. So next time I try to execute, I should replace it with some other page, or I have to execute that program at least next time. So OS looks to another table to decide now. So it has to check for another table. It has to check whether if there is in another table, if there is a invalid reference bit, then again I will abort that process. That means what? It is not in the memory. So what is that OS can do now? It has to get an empty frame. If OS will find an empty free frame, then it can swap that page into the frame. Then it can reset the tables. Then you can set the validation bit to 1. So before it was 0, now it will set it to 1 once it will get the free frame. So now whatever the process you have terminated, no, that you are going to restart. You can go for so many techniques. I will go for 3 types of techniques in page replacement algorithm that will be discussed later. So maybe one of the page replacement algorithm is specified here, is recently used. So based on that, whichever recently used, that we are going to move it. Then once you move, the transfer is done, we'll do the auto increment decrement location. Based on that, whether you go for least recent or whichever further techniques we have, based on that we increment or decrement the location. So go with the next set of process. So the diagram is shown here along with the steps. Say for example, you want to execute the instruction load M. M means some data, right? So whatever the data you had, no, A, B, C, some pages. M is one of the page you can assume. So this you want to load this. So now this instruction when I am this page when I am trying to load it, when I am trying to map it, because of the invalid, I am unable to continue with this particular set of code. Therefore, there is a page fault, right? So in the step 1, I have identified that. So once I identify, I have to send the information. The trap is done to the OS now. So OS will come to know that there is a page fault. So OS, what is that it will do? It has to find another page table, and again it has to restart. So the page is on backing store. So whichever you want to execute, no, that in the step 3 you temporarily store it onto the disk. Step 4, you bring it to the physical memory where free space is available in the physical memory. Then once it is done, I have to just reset the table and restart the instruction. What is that I will do? I will reset the page here. Instead of this, maybe I will go for another valid bit here. Then I will go for the instruction. What instruction you want to execute here? Load M you can execute in the step 6. So if it is not invalid, there is no page fault. Then step 1 only you would have mapped to the free frame. Then swap in or swap out is not required. That time only you can finish off executing. But because of invalid, you need 6 steps to come back and restart. So this is how the page fault is going to be handled. The technique in which you are going to allocate, reset the page table. That is again that depends on the page replacement